Now in Python, there are some predefined sort of primitive types. Okay, uh, so the some of the primitive types are as follows. So you have the int for integers. Okay, these are whole numbers. Okay, whole numbers. I'm sorry, I'm sorry. They're not whole numbers, but these are numbers with negative from negative infinity essentially to infinity and no decimals. Actually, I think these are called whole numbers, but let's call it whole numbers anyways. Okay, so these are numbers with essentially no decimals, right? No decimal places in them. So whole numbers. For example, -100 is an integer. Okay, 1,000 is an integer. Okay, a million is an integer. Okay. By the way, no commas. I'm sorry, no commas between the number or no spaces even. Okay, so when you say a million, you'd have to say one and then six zeros, no spaces, no commas. Okay, anyways, so that's one type. It's called integers. Okay, and I'll tell you why I said int. That would be clear later on, but this int is sort of a function. It's a function. Okay, that can convert something to an integer. I'll explain what that is later on. But so the first type is called integers, which are essentially numbers but whole numbers, no decimals. Okay. The second one is called float or real numbers. Okay, these are called real numbers. So they're also called floating point numbers. Floating point. Floating point. These are real numbers, which is to say they have decimal places. Okay, they can have decimal places in them. So essentially, it's the decimal. The number after the decimal can be zero. So you can have things like, uh, let's say, you can have -100 decimal zero. Okay, so it can go from negative to positive, just like integers, but they would have a decimal number. Okay, so they would have a decimal. So example of this is decimal -100 decimal zero. You can have 3.14, right? So every number essentially can be represented as a real number. Okay, but sometimes it's useful to have integers. There are other reasons for using integers as well, but anything that you can represent with an integer, you can also represent with a real number, provided the number is not big enough. Okay, integers, the way it works is these variables, right? The variables, just like cups will have sizes. As you have, like, you have 8-ounce cup, coffee cups, right? 8-ounce, 12-ounce, and 16-ounce cups, right? Variables, the cups that you use to store data will also have sizes. Okay, and what happens is, given the same amount of size, let's say you have 8-ounce cup, right? The amount, or the sort of, think of it this way, you have the volume of the cup is same, 8 ounce, but the amount of milk it can hold versus the amount of coffee it can hold would be different, right? So that it's sort of the variables in computers in programming sort of work the similar way. So what you have is you have floating points and real numbers. Technically speaking, you don't need integers, right? Because any number that you can represent with an integer, you can also represent with a real number, but it's not the other way around, right? So -100, right? You can say -100 decimal zero. 1,000, you can say 1,000 decimal zero, right? Million, you can say million decimal zero, right? So any integers can be represented by real numbers as well, essentially. But what happens is, sometimes it's not worth it. Okay, it's not. It, it doesn't. If you know that you're going to work with integers, this decimal is annoying. Okay, that's the first thing. Second thing is, integers. The largest integer that you can store in a variable is larger than the corresponding real number. Okay, so strictly speaking, let's say you have the variable. If it takes like 4 bytes, the maximum amount, the largest integer that you can store is something like 2.47 billion, little more than that. Okay, whereas the largest real number that you can store would be less than that. It would be something like 2 to the 24, so on and so forth. Okay, so would be smaller, and this is close to 2 to the 31. This is actually 2 to the 31 minus 1. Okay, but so that's why we use different numbers. Okay, if you don't understand this point, don't worry about it. Okay, it's just I just went off a tangent right there. But anyways, so we have two of the data types. We have integers for storing whole numbers. We have floating points for storing real numbers. Okay, the third type of the data is text or str, string. Okay, it's also called string of characters. That's why it's called str, string. Okay, and the text data, as you might have imagined, stores text, right? So it stores alphanumeric, right, characters. So it will store things like um, hello, or it can store things like CSC 120, right? Or it can also store symbols, right? At the rate, hashtag, I don't know. It can also store just numbers. That's fine, right? So you can say things like 120. You can also do that. Now, obviously, because this number 120 is stored as a text, you cannot do calculations with it. You cannot add this 120 to another string, right? To another number, let's say 50, right? If you try to do that, it won't give you 170. It won't do that. Okay, that's although you'd expect that, but the type has to be the same, right? So the number 120 can be represented as a text or as an integer, depending on what you want to do with that number. Okay, so text is, or string is, alphanumeric. Okay, it contains letters, it contains letters and numbers, or it contains special symbols, right? Finally, the last type is called bool, which stands for boolean. Okay, boolean is a variable that only has two values. Okay, true, false. Okay, two values. A boolean can only hold two values, either true or false, as opposed to integers, right? An integer can hold an essentially a large number of values, right? Essentially, if it's an integer, it will store somewhere like uh, four and a half, 4.5 billion numbers, right? If it's a string, essentially infinite amount of strings can be stored, right? Infinite variations of strings. But a boolean can only store two values, okay, true or false. Now, one thing to note here is the reason these are sort of these int, float, str, and bool, the reason these are emphasized is because these are actually Python functions. Python, these are Python functions. These are Python something called classes. Okay, we'll not talk about classes in this course, but you'll understand what classes is if you continue uh, learning computer science. But essentially, classes is data type. Okay, it's a type of data. Type of the data. Okay, and these are also functions. Okay, so this int, float, string are used to convert data into strings and floats and strings and whatnot. Okay, we'll talk more about this in this course. In fact, in this module even. But right now, let's go to Replit and actually check a few things that we talked about. Okay, so here's my Replit. Maybe you can open up yours and then code with me, but completely up to you. So what I'm going to do here is I'm not going to code anything per se. I'm going to use this terminal right here. Okay, this part right here. And what I am going to do is I'm going to show you a function, okay, a sort of Python keyword that helps you determine the type of data of a variable, or the type of data that a variable stores. Okay, so let's start by defining a variable. Okay, so we define a variable a and store the value 5. Okay, so when you hit enter, nothing happens, but the variable a is created. So now when you type a, it will give you 5. Okay, So let's say you want to find out the type of the variable a. Okay, what you can do is you can just say type and then within parentheses a, type parentheses a, and it will give you, Python will tell you that this a is of type int, which means a is an integer. Okay, now let's say you want to change the value that a stores to something else. You'd say a equals 3.1414. Okay, so a now has a new value. Now you want to know what the type of a is. Okay, so again you type, you print, you type whatever, type a, hit enter, and now it says class float. So the type of a variable will change depending on the type of data that it stores. If the data changes and if the type of the data has also changed, the type of the variable will change, right? So a variable is nothing but essentially the name for referring to the data that it stores. Okay? And if the data type changes, the type of the variable will also change as well. Okay. Now so you can just click on this one and clear. Okay, just so you know. So let's clear this. A is still 3.14. Let's do this. A equals, let's say A is now a string literal. Let's call it hello. Okay. When you say type A, it will give you str, class str, which stands for string, right? Str is string. Now let's say you want a to be a boolean variable, right? So a can only store true or false. So you would say things like a equals true, and you print type a, hit enter. It will give you class bool. Okay, so depending on the type of data that a stores, its type will change as well. Okay, one thing that I sort of missed is that when you talk about literals, right? So literals are, remember, literals are values that do not change, right? So 5 is a literal, right? 3.14 is a literal. Okay, when you use literals, okay, just remember this: the string literals which have alphanumeric characters in them, they must start with either a single quote or a double quote, right? So you can say things like hello, right? Or you could say in double quotes, you could say hello. Okay, so essentially the same thing. In Python, for Python rather, it's the same thing. Both are hello, right? But you cannot say things like hello. Python will complain. It will say that I don't know what you mean by this hello thing. Okay, anything, if you don't uh, put hello in quotes, Python will think of or try to use hello as a variable, but the hello variable does not exist, right? Hello is a string literal that we have been using. Okay, so any string literal has to be enclosed within single quotes like so, or double quotes like so. Okay, the other point is uh, we did not talk about the bool data type. Okay, so if you go to our, if you go back to our slide, we have this bool data type, and bool has only two values, right? Two values. These values are true and false. These true and false are boolean literals. Okay, so if you go back to our literal slide, okay, we have numbers like integer literals like so, there's floating point literals like so, we have string literals within inverted commas, either single or double, and we also have boolean literals such as true and false. Okay, so when you say things like a equals true, a equals true, okay, and then print type a, What do you think this will print? This will print bool, right? Because the type of A is bool. Now though, if you say A equals true, but within inverted commas, within quotes, and then print type A, what do you think this will print? This will print string, str. This will print string, right? So do you get the difference between a true and a true within inverted commas, right? Anything within inverted commas is a string, okay? Let me clear this again. So another example of this would be, let's say you say pi equals 3.14, and then you print type of pi, and this will of course give you float, right? This will give you float, right? Now if you'd say pi equals, within quotes you say 3.14, and then you print the type of pi, it will say string. So anything that is within quotes, either single quotes or double quotes, okay, is a string. Python considers it to be a string. If it's not within double quotes or single quotes, it has to be either a number, okay, it has to be a number, such as you can say things like a equals 5, right? Or a equals 3.14. So it's either a number with or without decimal, right? It can be a true or false, right? A equals true is fine. A equals false is okay as well. Or it can be another variable. So you can say a equals pi. That's fine. A equals pi is fine. If you print a would now print, what's the last thing that we, so pi is 3.14, it's a string, right? So if you print a equals, we say a equals pi, and then print a, it will print 3.14 within quotes, which means it's a string, right? But it cannot say things like a equals b, because b does not exist. Okay, b does not exist. Okay, and remember that when we assign a value to a variable, there are only a few ways in which you can assign the value. You can either assign a value from a literal, like so, 5, 3.14, true, false. These are all literals, right? This is a integer literal, this is a floating point literal, these are boolean literals, okay? The other option is you can assign a value to a variable from another variable, and that's what we are doing here, right? So we assign the value of pi, right, to the variable a. So a and pi right now consist of the same value, which is 3.14, and it's a string. Okay, so you say type of a, it's a string. Okay, one more thing to note is that when you have numbers, right, let's say you say x equals 5, and then you print type x. This will print integer, right? When you say type of x, it will give you class int. It's an integer data type, right? But the same thing, it will change if you say x equals 5.0. Now when you say type x, it will give you float. Okay, so even though these are the same numbers, 5 and 5.0, essentially they represent the same number, but because you specified it's 5.0, Python was smart enough to realize that this must be a floating point number, which means you want the the operations that you can do with a floating point number would be slightly different from those of an integer. Okay, the amount of data that you can store would be different. So what you said is, let me store a floating point number because I want precision. Okay, I want precision. If it's 5.1, I would need 5.1 and not 5. You cannot round it down. Okay, so that's how we store data. Okay, and that's how we get the type of data. Okay, so the type of data can be obtained by using the keyword or the function called type. Okay, so any variable, so let's say variable a equals 5 and you say type a, this will tell you that the type of a is an integer. Okay, uh, another quick note, it does not just do that for variables. You can actually also, let me clear this, you can actually also call the type function on literals as well. So when you say type 5, what will this give you? That 5 is an integer. Okay, when you say type 3.14, sorry, uh, what will the output be? It would be class float, right? Similarly, you can say type, uh, you can say type, within inverted commas, you can say hello or hi. Let's say hi. What will this give you? What will this return? This will return string, right? You can also say type uh, true, type true. I'm sorry, type true. This will give you bool, right? Type false, also boolean, right? By the way, the true and the false, the T is capital and the F is capital, okay? And that's it's not case, it is case sensitive, okay? So you cannot say, for example, type true. It can't do that. It will say, Python will say, I don't know what this means, true. I don't, the true is not defined. I don't know what you mean. Okay, I don't know what this means. So you have to say true with a capital T, okay, false with a capital F. Okay.